Good morning, students. I am Dr. Ekta Jain from the Department of Physics, Barkatullah University, Bhopal. Today, I am here with the topic Laser Principle and its application, which has been taken from the fiber optics and laser physics, a very important subject in the syllabus of MSc Physics. So, before going on laser principle or laser amplification, I must throw some light on laser. What is laser? In a very short, a laser is a device that emits light through a process of optical amplification, which is based on stimulated emission of electromagnetic radiation. Laser can also have high temporal coherence, which allows them to emit light with a very narrow spectrum, that is, they can emit a single color of light, or we can say that the light which we get from laser is monochromatic. Now, come on the main topic, laser principle or laser amplification. So, there are so many steps of laser amplification, we will see one by one. So, here on this slide we are able to see a diagram which is named as A. What is going on here? As we all know that in the general condition, in the normal condition, all the atoms are in the ground state, that we can say that medium is in the non-excited state. So, what happens in figure B? After suitable pumping process, the material is taken into a population inversion state. So, I think I must clear a word here, pumping. Pumping is a process by which we can achieve population inversion. I must clear the word population inversion. Actually, what happens, as I told, that in the normal condition, all the atoms reside in the ground state, and through the pumping, all these atoms jump to the excited state from the ground state. So, the number of atoms has been inverted, means now the numbers are more in the excited state as compared to the ground state. This process is population inversion, and the method by which this population inversion is achieved is known as pumping. Now what happens in figure C? We see here that the spontaneous photons are emitted in the initial state in all the directions. And what happens in D? To generate a coherent light output, the photons that travel in a specific direction are selected while others are rejected. And to attain the maximum possible amplification of light, the stimulated photons are to be made to pass through the medium a numbers of times. And by passing these photons through the medium a number of times, what happens? The amplified beam will move along the same path and undergoes multiple reflection at the mirrors to gain the strength. So, what happens after gaining the strength? As the oscillation built up enough intensity, it emerges through the front mirror as highly collimated intense beam, and we can see from figure F that here the beam is emitted from the laser light is in the same phase, same frequency, almost the same amplitude. Means this parameters defines that these beams are coherent. So, as we have studied that coherence is one of the most important properties of laser light. Now, moving towards the next topic, as we know that in our syllabus there are 2 level, 3 level and 4 level lasers. So, we will see one by one. First of all, I must let you know why 2 level lasers are not suitable. As we can see in this picture also, 2 level means there is only 2 energy states, ground energy state and excited state. A ground energy state named as E1, number of atoms N1, and excited state named E2, number of atoms N2. here we can see that the probabilities of raising an electron to the upper level and inducing the decay of electrons to the lower level, known as population inversion, are exactly the same. So, optical pumping will almost only achieve equal population of two levels. This is why the two-level lasers are not suitable for the optical amplification, and which is essential for the laser principle. One more thing I want to add here, that ground state even is the most stable state and the lifetime is maximum here. But in contrast of this, the excited state is less stable and the lifetime of the atoms in this excited state is only 10 to the power minus 8 seconds. Now come to the 3 energy level and 4 energy level laser. Here I have differentiated both the lasers. As it is clear from its name, 3 energy level means there are only 3 energy levels, while in 4 energy levels there are 4 energy levels in that laser. So a 3 energy level laser means 3 energy states, E1, E2 and E3. As we have studied, into a 2 energy level laser there are 2 levels, E1 and E2. Here in 3 energy levels, E1, E2 and E3, there is an additional energy state, that is E2, and it is named as metastable state. Here E1 ground state, E2 metastable state and E3 excited state. As I have told that the lifetime of excited state is 10 to the power minus 8 seconds, while the lifetime of atoms in the metastable state is 3 into 10 to the power minus 8 seconds. So, in a 3 level laser, at least half of the population of electron must be excited to the higher energy state to achieve population inversion. And one most important point is, in a 3 level system, the laser transition ends on the ground state, as we are able to see here. What happens in 3 energy level laser? See, when we do pumping here, the atoms which are in the ground state will excited in the E3, that is excited energy level. But how it would come downward? So it will come like this. What is our first step? The atom will go from E1 to E3 directly, but it will not come from E3 to E1 directly. How it will come? It will come E3 to E2 and then E2 to E1. So the transition from E3 to E2 is fast, while the transition from E2 to E1 is slow transition. Here we will achieve the laser transition. Here we will achieve the stimulated emission. Now come to 4 energy level laser. In a 4 level system where the laser transition ends on a level above the ground state, which is quickly depopulated. A very important point. Here what we have seen in 3 energy level laser, we see that the laser transition happens in the ground state, while in 4 energy level laser, the laser transition is between E2 and E3. Right? So this is the main difference between 3 energy level and 4 energy level laser. The example of 3 energy level laser like ruby laser, while the example of 4 energy level is helium neon laser, carbon dioxide laser, anti-arc laser, etc. Now we should move to the next slide. Obviously the 4 energy level laser is updated. So why the 4 energy level laser is better than 3 energy level laser? Actually, the pumping operation of a 4 level laser is exactly similar to the pumping operation of 3 energy level laser. But The advantage of 4-level laser is low population to the lower energy state. So, to create population inversion, there is no need to pump more than 50% of the atoms to the upper laser level. This was the most important point about 4-level laser. Now, the last topic is applications of laser. There are so many applications of laser. Few of them are here on the slides. First, communication. So, we will see point-wise point. Due to narrow bandwidth, laser are used in microwave communications. Due to narrow angular spread, the laser beams have become a means of communication between Earth and Moon or other satellites. A laser radiation is not absorbed by water and hence it can be utilized in underwater communication networks. In the field of computers, by the use of laser, the storage capacity for information in computers is greatly improved due to narrowness of bandwidth. In industries, laser can focus into a very fine beam, resulting in the raising temperature about 1000 Kelvin. So, they can blast holes in the diamond and hard steels. The next application in the medicine, as we all know, microsurgery is also possible because laser beams can be focused on a very small area. And lasers are also used for the military purposes, like due to a high energy density, a laser beam can be used to destroy big objects like aircrafts, missiles, etc. in few seconds. As such, it is called death ray or ray weapon. For the weather forecasting, it is used for the pictures of clouds, wind movements, etc. And it is also used in laser photography. We can get 3-dimensional lensless photography through the laser. Thank you.